All right, so let's see. This first new PR, increased messenger apps on right. Uh, the author is reporting really big increases, which looks really interesting. For someone who knows the messenger code well, it would be worth looking and seeing if this is a good idea or not. But at least the numbers that are being reported are pretty massive, so that's exciting. There's another PR also related to Messenger and async connection. It looks really specialized, optimized check loopback connection. Um, I don't know if that actually will matter much in typical use cases, but anyway, people are looking at the Messenger code, which is good because that also was where I started zeroing in on some recent performance bottlenecks. There's a PR for the MDS to convert unnecessary usage of standard list into standard vector. That wasn't actually listed as a performance PR. I added it. It might not actually make any difference, but I figured this is the kind of thing that sometimes can. So anyway, there's that one. There are two PRs that closed this week. One is to update DM clock to the newest version that apparently has some kind of performance enhancements. I didn't see any numbers, but that's good. That also specifically merged to Nautilus, so that's we'll see how that goes. But it must have been important enough that we felt like we needed to get it in. The other PR that merged was one from Jason to improve object map performance under high IOPS. I guess that was merged by Trocini. I don't know if I'm saying that right or not, but I haven't looked too closely at that one. But anyway, yep, that's that. There's a couple of other new ones. Another async messenger optimization PR from Ma Jianpeng that was reviewed, but we're waiting on Nautilus to drop before doing anything with it. Another messenger PR from Ma Jianpeng, batch handling and send message. Apparently that didn't actually improve performance in the most recent round of testing, but at least to my eye, when I looked at it, it looks like the performance is all over the place, so we can't really draw any conclusions from those numbers. Probably better to go back and again look at perf results or wall clock profile and try to determine whether or not it's improving the behavior, even if the performance doesn't necessarily increase. There's an RGW performance PR, orphan fixes. If I remember right, there's a lot of low-hanging fruit in that one. It is being targeted for Nautilus, and it is in testing. We'll just have to see whether or not that is able to make it in time. There is a librd multiple cache writeback threads PR. That one's been out there for a little while now. I think Jason was looking at it and asked whether or not it's still relevant given PR 26675, which is basically not exactly the same thing, but accomplishes maybe some of the same goals with being able to do batching of sequential I/O operations and kind of move more, rather than using a cache, more like an I/O scheduler type system instead. That's very new, so I actually don't think I got that into the new PRs, which I should. But anyway, yeah, so there's discussion going on regarding that. And then finally, this PR for canceling ops in the messenger when ops are redirected. And Greg put in a new review and questions about whether or not the reward is really worth some of the risks, because there have been issues attempting the same thing previously. So yeah, that's kind of it for updated and closed stuff. There's a bunch of outstanding PRs with no movement. Probably the top three are the newest. It looks like this, again, more async messenger improvements. Greg approved and needs QA. Both of Adam's PRs are, I think, up there, but are still kind of ongoing. Optimization of BlueFS reads, periodic discard features in BlueStore. Yeah, just none of that stuff I imagine is going to land anytime real soon before Nautilus. So punting on them, but that's okay. And that's basically it, I think, for new stuff. All right. Before I get into the discussion topic stuff I have, would anyone like to bring up anything this week? All right. Well, then I will very quickly go over a couple of new things and then we'll wrap up. First is that in GDB PMP, I added the ability to do inverse wall clock profiling, or at least get inverse call graphs out of it. So this was added because we've been looking at OSDs in very low CPU usage scenarios where we only have maybe even a portion of one core. And that proved to be fairly useful. So it works. It's there if anyone wants it. Kind of useful. So the next thing is that we have been looking at OSDs in low CPU scenarios, and kind of as a result of that, what we're seeing is that we're spending a lot of time in the messenger threads, specifically locking in the logging code in Ceph. It's very unfortunate.
No, that's never been seen before.
Yeah, exactly. It's actually in these low CPU usage scenarios, it was the top consumer of time in the async messenger thread was the logging code, both contending on the lock and also doing all of this OStream append stuff. So we're looking again at debug messenger 1, whether or not we should be logging less. Sage wants to rerun tests, so we can do that easily enough. I think probably Greg has been the biggest advocate of leaving the messaging logging at the current levels so that it makes debugging user clusters easier. I don't want to discount that, because for the folks that are actually going through and looking at real bugs on user clusters, if that's useful, I don't think we should necessarily get rid of it. But it is a big problem especially for OSDs that are very CPU constrained. So we've got to figure out something. I'm wondering on the locking side whether or not we can replace the unique lock with a spin lock potentially. I haven't looked that closely at it yet, but maybe we can do something there.
Well, I will try to be far away from spin locks in user space. If the reason is about the cascade of increased CPU demand. If the code using spin locks, the process that owns a spin lock in a given moment is preempted, then all other spinners, all other guys wanting to take the spin lock will spin. It means huge increase in CPU usage.
Okay.
I'm afraid that spin lock is quite dangerous in user space.
Radek, what would you suggest?
Well, when I was last time when I was looking on the case, the most of the cost was located in one single call, get host by name or something like that. It was very, very costly, but still offers some possibility of caching. Of course, with all the drawbacks, like a necessity to take care about caching validations. Well, like just an increase in terms of complexity. Still doable, but makes the software more complex.
So that is one of the things I definitely did see. What I think I'm more concerned about, though, is like, I guess fpaste doesn't let me highlight stuff. I was hoping it would. If you look at like the messenger threads in this paste, look at like messenger worker 2, I guess. I think it's on line 1637. I mean, look at the logging behavior there.
Looking messenger workers 2. There. Okay, logging submit entry.
The mid-entry seems to be where we are really contending. And that was the case when I had a couple of messenger threads like this, but just in general. And we see it in other parts of the code too, where we're also doing logging. I think it was in
Okay,
I forget, somewhere in the OSD.
I was taking a look using perf. I wasn't concerned about the wall clock. I was concerned about cycles burned in the messenger threads.
I see.
But
okay, sure.
But we are crafting those lock messengers under a lock.
Mm-hmm.
So it can translate into much bigger impact when it comes to wall clock.
Yeah.
Wall time.
The fact that you were seeing it consuming cycles too in perf, I mean, when the wall clock and the perf agree like that, it's...
I still have a gist about that. Let me... Okay, got it. Loading. Got the link. Here it is.
All right, taking a look.
But it's from, well, it's from, what is the date?
So you're seeing most of it from get name info. Okay.
In that particular case, should we really be calling making such calls in a hot path?
Yes, we are.
No, but right, but what? But what if we stop?
It's because of our debug level of messengers debug entries crafting. We are.
Well, just going back for the 7 or 8, 9, 10, I don't know how many years now. We started doing this, and it's not that long. It's 7 or 8 years. It goes from back to year 0 for us. Turning off logging to make it simply all logging was the only way to get within 2 orders of magnitude of actual latency in any measurement. So it's obviously huge. We've talked about solutions a lot, but pre-computing on one hand, pre-computing everything and moving less data into the log seems like ideal starting points, and then past that, finding some efficient way to slot it so that we're not so that we reduce contention. Because as you point out, I don't agree with the statement about spin locks in user space as being the gloss, but when there's high contention, it's terrible.
Yeah. I think what it really comes down to is how useful is debug MS1 for
But
users.
Vtex isn't any fun either. It's better, but then you get a crazy and a bunch of other crazy stuff.
Yeah.
But the real problem is that we don't know whether the debug MS equal 1 is really necessary. We are programmers. I have zero knowledge about the real usefulness of this thing when it comes to seeing it from operator's perspective. I just don't know.
So I think Greg has fairly. I don't think I'm misrepresenting his position that he feels pretty strongly that it's very useful for debugging user clusters. I don't want to necessarily. Yeah.
Sure.
In that case,
if I can add something. Oh, sorry. Can you guys hear me?
Yes.
Yep. I'm working on a PR. I've talked about this a while back for using LTTNG for logging.
Yes.
And I did actually benchmark. I did change the logging in BlueStore, only in BlueStore.cc, so only the BlueStore file. I moved from our old logging to LTTNG. And I tested it on a real cluster, but pretty old hardware and just spinners. The gain is not really sure. I mean, in some cases, good. In other cases, I'm not sure there's an improvement. There's a huge gain in space used for the actual log files. It's 70% improvement. But in terms of performance, I couldn't really see anything that is conclusive on old hardware.
Going back 5 or 6 years, we did something similar in cohort. We had the same experience. We got a big speed up in logging when we consolidated things into a reformatted buffer and shrunk it and introduced thread local caching of that buffer.
Yeah, exactly. In terms of space.
But yeah, LTTNG hits a fence that's very similar to the spin lock.
Yeah, I assume so. Yeah, I mean, I could do the same experiment for the messenger as well. I mean, that was actually my next step, because if there's no improvement in BlueStore, I mean, I want to see if that change would be warranted, so I can look at the messenger as well.
The big ones, Mohammed, if you could look at, do you have a source tree handy?
Yeah.
In message dispatch queue, pre-dispatch, that's one to look really closely at. Just basically everything in dispatch queue, actually. That would be a really useful place to start out, I think.
On source messenger and source.
Yeah, messenger/dispatch queue.cc.
Okay, yeah. Anything there, right?
Yeah. So like, do you see pre-dispatch? It's right at the beginning.
Yep, the first one, yeah.
Yep, that's one to check out closely if you convert that. And then also just in general in here, there's that's one of them. Let's see.
Honestly, just by looking at the speed dispatch, there's a lot of string manipulation, like concatenation. I mean, just that it doesn't. I mean, I wonder if just reformatting it.
I was wondering that too.
Yep, that's the difference. We need to differentiate between logging the bugs and crafting the bugs.
Yeah.
In many cases, what is the real pain is just crafting. And even if we exchange our logging infrastructure with something extremely fast, extremely performant, we won't see huge difference.
Exactly. And one of the things about LTTNG is that it kind of restricts you of how you can craft your payload, which can be good in some cases. So, I mean, it kind of forces the developer to think about how to craft it, as Red is saying. But yeah, to your point, that's completely true. I'll look into this one specifically.
Cool. Yeah, I think that is exactly the message that Greg cares about too, if I remember right. So that one's a very worthwhile one to look at. All right, cool. Let's see, did I have anything else in here? So I guess the only other thing is that there's a lot of stuff that hasn't helped yet. Debug MS1 and this stuff looks like it's kind of the big thing right now. And then just general memory management and object life cycles. We have all kinds of stuff that gets created and deleted all over the place, and it's spread out. But the less we can do that, probably the better. So if you know your parts of the code, and if there's stuff that we can do to avoid creating and deleting objects all over the place, that's probably a worthwhile goal.
Object lifecycle, could you?
Sorry, I mean like just there's a bunch of places where in profiling all this stuff where I'm seeing that we're just creating temporary objects.
Oh, I see. Allocator. Yeah. Frobbing new operator.
Wow. Yeah, exactly. And I don't know how much of it is really needed versus where it's, it would be difficult to change, but I see it semi-regularly in profiles where we have temporary objects that, the creation and deletion of them is overhead. So anyway, that's basically it. Any other questions or thoughts, guys? Any of this?
I had a question that kind of came from downstream, but it needs help upstream, and I figured Radoslav would be here to talk about it.
Sure,
other people can feel to help as well. People are asking us about the overall level of our CPU architecture and related optimization, which I didn't know how to even tell them the good answer to that. And not only that, is obviously there are various interesting subsystems and engagement with different libraries and different platforms. I don't think we're really capturing this anywhere. Whenever we package things up, though, we shouldn't we, or could we?
Sorry, are you thinking about having a list of our dependencies on external libraries?
I mean, kind of like constructing a sort of a readout or a list, or a report of the different optimization levels of the different components pulled out from that list and from our compiler options as given. So that you would be able to say, well, if you're using Erasure coding, we built it this way with these CPU architecture optimizations plus,
okay.
There's an assumption of SSE42 plus, then for crypto
I see.
this and.
For sure. I don't think we have such thing right now. Might be useful. Especially for crypto, especially for Erasure coding, all that CPU crunching intensive things.
Yeah, I mean, it seemed like that's what I was getting at, because it seemed like we've in the past had a situation where we missed a lot of acceleration we weren't getting, say, in maybe some of the crypto.
Yeah. But wouldn't it apply solely to the things that are under control, under our control? I mean, especially those things like iSale crypto, all those dependencies we are compiling all together with Ceph. Because I guess we don't want to introduce our own version of, let's say, libcrypto, compiled with some specialized tuning, some specialized optimizations, compiler flags. Well, I guess we want
I don't want to bike shed it, but I'd like to have it always visible. Because maybe I do. But I don't want to just for fun. But I want to know.
Okay, but well,
if we realize that we're getting in in the case of crypto, as you mentioned, I mean there are reports we've had some from downstream, we've had some from upstream. There are places where there are environments where we are getting terribly bad acceleration
Okay.
in key paths, like with SHA.
Are we ready? Okay.
And
Sounds like we are ready to. I assume we are ready to even exchange the standard, the crypto library, the package, RPM, for instance, provided by system vendor with our custom version, right?
Well, not necessarily, but that's one option. But I mean, we noticed too, libNSS to OpenSSL. It seems like we get better on a bunch of platforms now. OpenSSL has got better acceleration. Once this is done, maybe this becomes somewhat moot. But there might be some place where we discover it's desperately important, and if we're not watching it, we wouldn't notice.
That's true. We don't have such list at the moment. But this is also, well, constructing the list ex-house libby would require also some involvement with guys from, well, let's say, HL, from system, from the vendor of your operation system, because we are using a lot of external libraries, especially for crypto. I'm not sure about Erasure coding. For Erasure coding, we are using our own, integrated in the repo, I guess.
Yes, I don't have a direct action on, but kind of food for thought. I mean, I think
what I'm afraid about is if we try to poke with optimizations, we can hurt generality. We could end with the necessity to provide a set of different tastes of a given library. One compiled with, for instance, with SSE 4.2, one compiled with SSE 4.1, all that stuff, all that possible variants. It can be painful. Well, cannot say at the moment, to be honest. Maybe it's worth the effort.
Matt, the cases that you guys saw where there were problems, was that due to not the right version of different algorithms being implemented, or was it not good use of them? Or?
Most clearly, I don't have a number, but maybe someone will find it. There's an upstream remark in the Ceph tracker about SHA-256 computation.
Okay.
That's one, and that's a pretty big one for RW and S3, and not to mention a lot of other things, I suspect, floating about. And performance with SSL, so with TLS, with on the Luminous time frame was pretty, and on some platforms was pretty terrible too, and probably because we're not getting acceleration, or maybe even AES. I don't think that's such a general problem, but I think SHA-256 is a good example.
When you say not getting acceleration, is that because we're not using the right implementation, or is it because?
Yes, most likely, yeah.
Okay.
In that case, it's all loaded something else. It's open, with libNSS, I think, and then but in the case of the SHA stuff, it's the same thing, I guess. I mean, but it's different.
Okay.
Different implementations.
And we've kind of continually had issues with the build, right, where certain libraries don't get detected right and certain stuff doesn't get detected right. It's something I feel
that's not the case, I guess, because we are in the matter of crypto, especially in the matter of libcrypto.sl. I'm pretty sure we are depending on external version provided by the OS. I wouldn't expect that we are linking with our own libcrypto. Basically, having our own libcrypto build would mean that we are also taking responsibility for, let's say, maintaining insecurity, porting patches, porting security fixes, all that stuff. But we could try to ask the vendors of these libraries inside Red Hat to turn those optimization on. Maybe it's just missing a possibility. Maybe it's not limited by the set of hardware we really need to support.
Trying to look in the tracker to see if I can find the PR you're talking about, Matt.
Okay, it should be. Yeah, I can help too. But there was this easy to find, I think. Yeah, I apologize for not searching for it already.
Here's the list I'm looking at, Matt, just to see if I could find it, but might not be. Maybe I'm not looking up the right thing.
Yeah, that's not what I'm thinking of. One sec.
In the meantime, I had a question for folks. Does anyone know?
Here's one.
Oh, excellent. Okay.
I have, yeah. I think they used the hyphen form in the SHA.
Okay.
So what these guys see is pretty definitive. We'd be getting either.
It's with libNSS.
Yeah, that's right.
Well, NSS is not too performant. I'm not surprised.
So yeah, I'm not calling out a desire to make a big mess, but I'm calling out a desire to spot maybe what I would most interested in doing is having the tools to spot off, but also if while we're on the conversation, if shifting to some other, making a couple of shifts gets us a lot of things at once, we might, this example might suggest that we're at a place where we want to make sure we get there.
We're moving away from libNSS and the OSD, right, Radek?
Yes, we already did.
Yeah.
At least for Ceph. What is basically with the commit merged today, we should be free of NSS usage, not compilation on NSS usage on the Ceph OSD. The last thing it was needed for was the SHA-256 HMAC implementation. I moved it to OpenSSL. Let me find a link.
This is precisely the kind of thing. Yeah, this would be, if we're not already doing this, and we were discussing this in another thread, but if we haven't already doing this in RW,
it was taken to master today. Let me.
Is this generalized to our code base or not? In source code?
It's generalized. It's generalized. You should be able to use it. You should be using in RGW without any need.
Code changes.
Without any code changes.
Radek, is that targeted for Nautilus?
Yes, it will be.
Okay.
It will be in the release. Got the commit. Okay.
I can probably find it, but that'll be useful.
Got the commit. Here it is.
Because I think we would like to look at we can discuss this out of band, but I think this is something that we might want to take further back and discuss in the context of other things.
If you can, if you can even do this as a backport to Nautilus after the release, if we can do this in RGW2, it'd be really nice to get libnss out of the picture.
As far as I know, RGW
I think it's likely that we will highly prioritize taking this out.
Yes, if I recall correctly, RGW has a dedicated wrapper for calculating the HMAX, something like calc HMAX SHA-256. Yeah. It internally uses our Ceph crypto HMAX abstraction. It was till today, it was implemented on top of NSS. Even after the transition of our hashing stuff, it was using NSS. Because, well, OpenSSL had some divergences when it comes to HMAX support between versions. This commit eradicates that issue, and RGW should be able to utilize OpenSSL for.
I think what you're really saying is it will transparently utilize.
Yes, transparently without.
Yes, that's genius. But I think
that's good. But the RGW SSE encryption stuff that Adam Kupchik did is still using some custom.
Yes, that's the last. We talked about that in the kitchen.
But still, yeah. Okay, so there's further work to do. But this alone is a huge one. Which is a small. There's no small thing. Because this probably addresses that tracker issue completely. Someone should do some measurements, but if that's true, this could be a very large speed up or a very large reduction in CPU, depending on.
Under assumption that the HMAX in OpenSSL are more performant, I feel they are, but it's only my feeling, to be honest. I haven't benchmarked the HMAC implementation in OpenSSL.
But when I say they're not, I mean the experimentation was something with other this is an area of concern. So, but it sounds like this is a huge win by itself. We saw a lot of evidence that libnss was underperforming with TLS, and so that's different. Although it's a problem, or I think it is.
Well, I don't know. I haven't marked the commit as performance-related one. The main reason for committing the change was that we don't want to use NSS anymore. But it can be that it potentially has nice side effect of being more performant.
No argument there, I guess.
And according to
but it's something to actually measure, because I think I want to understand this, and be able to have this conversation over time.
Yep, and even it's still good, even if OpenSSL lacks some optimized. Even if OpenSSL we ship in OS is not using some optimized versions of the algorithm implementations, well, it's still easier to make the transition while having when only single crypto library needs to be addressed.
And I guess also I've forgotten this, but I exchanged email with or custom becoming this GitHub comments with one of the developers at BBC, and he was proposing, or they were proposing that they had experimented with using the asynchronous interfaces, and in OpenSSL, and saw a large CPU reduction from that. Which they apparently have a patch set for RGW. So,
okay.
How do the asynchronous interfaces work?
Well, there's just different setup and completion logic, I guess. I've never implemented them, but Marcus and
well,
I probably have.
Do we know why it reduces CPU usage?
Just because it's getting a bunch of interleave scheduling, I believe, offload.
Okay. I can recall that Intel made us a dedicated patch set just for OpenSSL, just to bring the asynchronous variant of API. It's extremely important if you want to have, if you want to put some calculations related to crypto on, let's say, crypto as QAT.
Is
QAT
it
count.
is it just because now it can batch them? Is that kind of the big gain?
Well, I guess it's because those accelerators are very good when it comes to bulk crypto.
Yeah, okay. Yep. Cool.
Like with just like with our GPU.
Yeah.
Processing of single request is, I bet it's quite slow, but you are able to process a lot of them at the same time.
So I imagine for like big IOs, we can do that. How much do you need for what's like considered bulk in this case? Is it small enough that even like small IOs in our context are still bulk for them?
The answer is yes, because the PVC workload was just running requests against S3.
Okay. Cool. Sounds good.
Not object size, but probably, I'm just guessing, it probably skews towards some normal distribution of 100K or something like that.
I bet for bulk for them is like, tiny for us, right?
If I had to guess, I mean, I would expect if you look at this, but this is, we're talking about signing request bodies, basically.
Yeah.
Well, taking the opportunity, maybe a different but somehow related question about RGW. Do we still need the PKI legacy set, PKI token legacy thing support in RGW?
What's it used? I mean, other than the ridiculous.
Keystone PKI tokens. The main problem.
Well, I don't know the answer. You and Marcus and I can talk about this offline, or we can talk.
Okay.
I don't know the answer. It's not a secret, but I mean, we need Keystone. Do I need that poo from?
Definitely. For sure.
No, I don't give a hoot about those APIs. And in fact, moreover, you're the expert here, but you and Marcus are, I guess. But if we're saying for other reasons, for like very compliance reasons and stuff, we can't use them anyway. I mean, I'd sure like to get rid of them if there's some other way to do the same work.
The sweet side, the sweet side of eradicating the PKIZ
is the
legacy kind of stuff.
Let me ask more clearly. I think I'm just getting it now. Are you saying that in order to discard that, we would have to drop support for PKI tokens in Keystone?
Well, maybe we don't need, but it will be much easier to get entirely to OpenSSL if we strip the support for legacy tokens of Keystone. I mean the PKI and PKIZ.
Yeah, no, I get it. I don't know the answer to that, but we can go find out.
Anyway, if I recall correctly,
I think they're deprecated, but I don't know when they're gone.
Yeah. Well, if we cannot kill this thing, we will need to find a counterpart of CMS support in OpenSSL. In SSL, it's definitely available. I don't know about OpenSSL version. Maybe it's there. Just need to find. But basically,
let's talk about that. Let's talk about that in our FIPS thread, downstream. If we can find a downstream excuse to shoot this in the face, I'll take it.
Cool.
All right, guys, we've got a little bit of time left. If anyone else has anything they want to talk about, otherwise we can wrap it up.
I'm missing my downstream meetings or offstream meetings, so I got to disappear my RGB meeting. But thanks for the feedback, Ross. I thought that was really helpful.
Cool. All right, anything else, guys? All right, well then, let's adjourn this meeting, and we'll possibly get back together next week with Nautilus landing soon. Everyone's really busy, so we'll kind of see if there's anything to talk about, but let's plan on next week, and I'll send out an announcement if we end up punting, just because people are working on stuff. Anyway, have a good week and see you later, guys.
See you. Bye.